Asteroids. They come in all shapes and sizes. Thankfully, though, the larger, potentially world-ending asteroids are rarer and less likely to fly close to Earth. However, we of course know that massive rocks have struck our planet before, in its ancient past. And so the question for a long time has been whether or not humanity would be able to defend itself should another asteroid ever head our way. But now, NASA has settled that debate. This is Unveiled, and today we're answering the extraordinary question: did NASA just save us from another asteroid strike? Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. A natural disaster sent from outer space has the potential to be truly apocalyptic. Big enough rocks that rain down from space really do threaten to wipe out most, perhaps even all, of life on Earth. And it's something that has already happened a few times before. The most famous of these mass extinction events of the past is the one that killed off the dinosaurs, the KPG event, which was most likely caused by an asteroid strike and its resulting effects. Naturally, the impact of an asteroid itself is bad enough to begin with, but it's ultimately what follows that causes the long-term and immeasurably difficult issues. It's thought likely that the KPG event, for example, spawned fires, massive earthquakes, and tidal waves. It sent hurricanes across the planet and plunged once peaceful lands into months and months of darkness and extreme cold. In short, Earth was a nightmare following the impact, and that nightmare lasted for a very long time. By some measures, for thousands of years. Perhaps the most concerning part of the often told story of the end of the dinosaurs, however, or indeed of the prospect of any large asteroid strike, is that if the same thing were to happen again, there'd seemingly be nothing we could do to stop it. But that might now have finally changed. Over the years, many different theories and suggestions have been put forward on how to stop an asteroid impact, but often they're not all that practical or effective in real life. For instance, the Hollywood go-to of just blowing it up with a nuclear bomb might work to some degree, but it also might send a scatterblast of smaller radioactive debris towards us instead. Not good. Or else even a nuke might not be powerful enough to divert an asteroid with any significance or control. The better strategies have tended to revolve around diverting the rock, though. In general, it's thought that deflecting a potential impactor could be a much cleaner and safer way of handling the problem. Previous theories on how to do this have been as bizarre as painting an asteroid white to trick the sun's light into pushing it out of the way for us. However, while that idea never really caught on, NASA and the European Space Agency, ESA, have finally settled the matter once and for all. In 2015, the two organizations began working on an incredible joint project, an asteroid defense system called DART, or Double Asteroid Redirection Test. Since then, it has become an international effort, with NASA leading the charge. In November 2021, the mission was launched. In September 2022, it reached its final destination. And in October 2022, the team behind it discovered that they had been successful. For the first time ever, human beings had redirected an asteroid from outer space. The DART mission was specifically designed to test the theory of redirection through kinetic impact, which in concept is extremely simple. It says that if an asteroid has a set trajectory along which it's traveling towards us, based on things like its weight, speed, and positioning, we should be able to change its path if we just slam something big enough into it with enough energy. So that's what NASA decided to do with two asteroids that posed no actual risk to Earth. Mission organizers were keen to emphasize this throughout. At no stage was their target actually heading for Earth. The goal was simply to test whether the plan and technology would work. Plus, the asteroid they chose was positioned in such a way that even if something had gone wrong and the test had backfired, there was never any possibility that it would affect our planet. The exact target was an asteroid called Dimorphos, which itself orbited a much larger asteroid called Didymos. And the team knew that if they could alter Dimorphos in its orbit, they also had a chance of being able to do the same to another, genuinely lethal asteroid in the future. Again, they just had to hit Dimorphos with enough energy. Enter the DART spacecraft. On board, it contained nothing besides navigational tools to reach its target, like cameras, thrusters, antennas, and solar arrays. Nevertheless, it weighed a total of 1,340 pounds, or 610 kilograms. A giant in the void, traveling for almost a year from here to there. DART was accompanied by, or more precisely carrying, another smaller spacecraft though, called the Licia Cube, or Light Italian CubeSat for Imaging of Asteroids. The Licia Cube had the purpose of separating from DART at close to the end of the mission, in order to monitor the event and let NASA know whether or not the test had worked. What happened next was truly a world first. Or should that be solar system first? On September 26, 2022, the DART spacecraft successfully impacted the asteroid Dimorphos, leaving a sizable crater on its surface. NASA live-streamed the event, and viewers watched from around the world as DART approached the two-asteroid system, before finally honing in on Dimorphos, with it getting closer and closer out of the darkness. Then the feed was cut off by a red screen. The craft had lost contact and smashed into the rock. It had been traveling at a speed of 14,000 miles per hour, and researchers are still running calculations and observations to learn precisely how much energy the craft transferred on impact. But in general, the results show that DART was a major success. Previously, the only similar kind of data to that which DART provides was obtained by NASA's Deep Impact spacecraft in 2005, which plummeted into a comet in order to study its composition. The mission had hit with a force equivalent to 4.7 tons of explosive TNT. But for the DART mission, NASA's metric for success was different. The main goal was to alter Dimorphos's 11-hour and 55-minute orbit around its companion asteroid by a minimum of 73 seconds. This could ultimately show that there is enough promise within the technology to save Earth from a future asteroid strike, should we need it. And on October 11th, a little more than 2 weeks post-impact, after calculating an updated orbit for the asteroid, NASA announced that it had surpassed its goal by a factor of 25. The DART mission had actually altered Dimorphos's orbit by an astounding 32 minutes. This then marks a huge accomplishment for NASA, but also for space research generally, for humankind, and for Earth. As NASA Administrator Bill Nelson said, in response to the DART results, quote, "This mission shows that NASA is trying to be ready for whatever the universe throws at us. This is a watershed moment for planetary defense and all of humanity." End quote. DART marks the first time in history that anyone has ever successfully altered the orbit of another planetary body in space, and it proves that the math and science behind asteroid redirection is sound. What's more, as well as impressively altering Dimorphos's orbit, there are some predictions that the debris broken from Dimorphos could also impact its neighbor Didymos, changing its path as well, which means that eventually it might be more than just one asteroid that DART has been spinning elsewhere. Perhaps there is still one final problem to solve, however: time. While we have now shown that we can deflect an asteroid if we want to, it took us many months to do so, not even counting the prior planning and building of the craft itself. And although NASA does keep track of the asteroids around us, and there are no immediate threats right now, space is an ever-changing landscape that's always keeping us on our toes. Maybe the next challenge then is to reproduce DART, but do it quicker, from launch to impact in a shorter and shorter time window, so that we're always giving ourselves the best possible chance. But for now, hat tip to NASA, ESA, and all who worked on the mission, the research, and on making what was once pure science fiction into a real-life possibility. Because that's how we may have just been saved from another asteroid strike. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.